In this video, I'm going through S1, Chapter 4 and Section 4.4, which is about set notation and how we're using it with probability. So you can use set notation to describe events within a sample space. This can help you abbreviate probability statements. The event A and B, which is talking about the overlap between A and B, what they both have in common, we use the symbol for the intersection, or we use the word intersection. So we would write it as the intersection of A and B. And of course, when the events are independent, the intersection of A and B is the probability of A times the probability of B. If two events are mutually exclusive, if they don't have an intersection, if they don't have an overlap, then the intersection is empty. It's a null set. And you can write this in this way. The intersection of A and B is empty. If you see that in a question, they are telling you that these events are mutually exclusive. The events A or B can be written using the symbol for the union. So the union of A and B is all of A or all of B. And if the events are mutually exclusive, we find the union of A and B by adding the probability of A to the probability of B. The event not A can be written as A with an apostrophe, which means the complement of A. And of course, we find the complement of A by doing 1 minus the probability of A. And the events A and not A are always mutually exclusive. They cannot happen at the same time. They do not have an overlap. Now, the first thing I want to do is look at a shading exercise. It's a GCSE shading exercise, but I think it helps. Also, I want to show you a method that I use, because sometimes people can see this very easily and interpret the different areas and the different regions very easily, and sometimes they don't. So I want to show you a method that you can use. It doesn't matter how complicated the notation is, and it will always give you the region that you are looking for. And we're starting kind of easy. So the first part says shade the complement, the union of the complement of A and B. So what I do is I number each little part of my Venn diagram, 1, 2, 3, 4, so each separate region. And then I split my question into a list of numbers. So the complement of A, not A, is 1 and 4. And then B is 3 and 4. And this says the union, which means I want everything in the list, 1, 4, and 3, and that is what I shade. So I'm shading the outside, and I'm shading all of B, because I want the union of the complement, not A and B. The union means everything. The next one is actually pretty easy, because I already know what they want in the bracket. What they want in the bracket is what I've shaded here, but then outside the bracket it says not that. Whatever's in the bracket, that's not what I want. Well, the only remaining area is this one. But I would have done it the same thing. I would have done the brackets first, found out the area that I want, and then what I don't want. The next one says I want the intersection. So this time it's an intersection, what they have in common between A and the complement of B. So I'm going to number this 1, 2, 3. A is 2 and 3 because B is a subset of A. The complement of B is 1 and 2. And the intersection means I'm only interested in the overlap, what the two lists have in common. And the two lists have 2 in common, which means 2 is what I'm shading. I'll do the same here, 1, 2, and 3. I want A, which is 2 and 3. I want the complement of B, which is 1 and 2, but this time I want the union, and the union means everything, 1, 2, and 3. So that means I want to shade the whole Venn diagram. This one is easy. It says I want the complement of B, which basically means I don't want B. So here is B, I don't want it. The areas that I want, that I'm going to shade, are everything that isn't B. Next one is also easy because it says I want the intersection between A, B, and C. The only place they all have in common is this. That's what they have in common, the intersection. For the next one, I'm going to number. So 1, 2, 3, 4, 5, 6, 7, and 8. The complement of A, not A, so I'm kind of doing that. I want 1, 8, 7, and 4. 1, 8, 7, and 4. B, well, B is straightforward. It is 3, 4, 6, and 7. The complement of C, not C. 1, 2, 3, and 4. And it's the intersection. What do these three lists have in common? They don't all have 1 in common. They don't all have 8 in common. They don't all have 7 in common. What about 4? They do have 4 in common. What about 3? They don't all have 3 in common. They don't all have 2 in common. They don't all have 6 in common. Okay, so the only part that I'm looking for is this. That's the part I want to shade. And I'll do exactly the same with the next one. 1, 2, 3, 4, 5, 6, 7, and 8. And I'm going to deal with the bracket first. I want the union of A and B. Well, all of A and B is 2 and 3 and 4 and 5 and 6 and 7. I also want C, which is 5 and 6 and 7 and 8. And I want the intersection between those two things, what the two lists have in common. They do have 5, 6, and 7 in common, so that's what I'm going to shade. Okay, and the next one, I'm going to do the same. 1, 2, 3, 4, 5, 6, 7, 8. I want the intersection between A and B first. So the intersection between A and B is 3 and 6. And then C is 5, 6, 7, and 8. And I want the union. So 3, 5, 6, 7, and 8. That's what I want. 3, 5, 6, 7, and 8. Again, I want the intersection between A, B, and C, but I want the complement of that. The complement of the intersection. So I want everything that isn't the intersection. That's what I'm shading. I'm going to shade all around the intersection and all around the outside as well. That's the bit I want to leave unshaded. I'm going to again do my numbering. 1, 2, 3, 4, 5, 6, 7, and 8. This says I don't want the union of A and B. Well, here's the union of A and B. All of A and all of B. So really, if I don't want that, the complement of the union of A and B is 1 and 8. Let me try and take my scribbles out. That's it. And then C is 5, 6, 7, and 8. And I want the intersection between these two. And that's just 8. That's the part I want. And for the last one, I'm going to number 1, 2, 3, 4, 5, and 6. I'm going to deal with the bracket first. The union between the complement of A and C. Well, the complement of A, not A, is 1, 5, and 6. And C is 4 and 5. And I want the union between them, so that means 1, 4, 5, and 6. So that's my final list, 1, 4, 5, and 6. And then I want B, and B is 3, 4, 5, and 6, 3, 4, 5, and 6. And I want the intersection between those two. So that is 4 and 5, 4, 5, and 6, 4, 5, and 6. So that's the part I want. 4, 5, and 6. Okay, let's look at this question. It says a card is selected at random from a pack of 52 playing cards. Let A be the event that the card is an ace. So an ace or a 1. So the probability of getting an ace is A. And then let D be the event that the card is a diamond. Well, the diamond pack is this pack. All of this pack is the diamond. So that's D. And that's our pack of 52 cards. They've also introduced a new notation, although you should have seen it at GCSE, and it says the number, when you write n brackets A, it means the number of outcomes for event A. So as we saw, there are 4 aces in the pack. So the number of event A is 4. But there is only one card which is both an ace and a diamond. So the intersection, the number for the intersection between A and D is 1, only one card. So for question 1, they said find the probability for the intersection of A and D. Well, that is 1 out of 52. And then for B, they say what is the union, the probability of the union of A and D? Well, the union is everything, all of A and all of D. Now, notice that this is repeated. So 4 cards, and that's 13 cards, but actually one of them is repeated. And if we count, we've got the 3 cards, this one, this one, this one. We've got the repeat card, that one, and then we've got the other 12. So altogether we have got 16 out of 52 cards for A or D. Everything in event A and everything in event D. And then the probability of not A. So I literally don't want that. I don't want any aces. So these are 12 cards without the ace, because there are 13 of them, and that's 4. So 12 times 4 is 48. I have 48 cards, and so the probability of not getting an ace is 48 out of 52. And then the last one is the probability of not getting an ace, and it's the intersection of D. So I will put that in a Venn diagram. might be a good moment. If you're thinking, how do I do that? Think of Venn diagrams. And the only thing I'm going to include is the probability of A and the probability of D. Remember, we already know that there is an intersection. So I know that A is 4 cards. One of them is here, 3. And I know that D is 13 cards. One of them is in the intersection, so that the remaining is 12. Once I've done all of A and all of D, okay, I know that there's 52 cards altogether. 52 minus 16, which is the amount of cards I have in A or D, is 36. So outside is 36. And I do what I did before. I have complement of A and D. Well, the complement of A, not A, is 36 and 12. And D is 1 and 12. Well, what do they have in common? Because it says the intersection. Well, what they have in common is just the part of D that's just the diamond. That's what we're finding. And that is going to be 12 over 52. So when they start doing this kind of more difficult notation, put your information in the Venn diagram and then do the list like we did before, and you'll know which area you want. You're looking at just D, and that's 12 over 52. The next question says, let's make it bigger. Given that the probability of A is 0.3 and the probability of B is 0.4 and the probability of the intersection of A and B is 0.25, explain why events A and B are not independent. So we'll take it one step at a time. If the probability of A and B is independent, that means that the probability of A and B, the intersection, should equal the probability of A times the probability of B. Well, the probability of A and B is given, it's 0.25. The probability of A is 0.3, and the probability of B is 0.4, which is 0.12, and it's not. They are not equal. 0.12 does not equal 0.25. Therefore, the probability of A and B, therefore events A and B are not independent events. And then it says, given also that the probability of C is 0.2, the events A and C are mutually exclusive. So A and C are mutually exclusive. That means they don't overlap. There's no intersection. And the events B and C are independent. Well, B and C are independent means that the probability of B and C is the probability of B times the probability of C. But it also means there is an overlap. There is something called the probability of B and C. So B and C overlap. And then it says, draw a Venn diagram to illustrate events A, B, and C showing the probabilities for each region. So really important, so showing the probabilities for each region. Okay, so I need a rectangle to start with. There we are. I need A and B to overlap, and then C is overlapping with B. I know that the overlap between A and B is 0.25. Let's make it a bit bigger so I can write. There we go. 0.25. And I know that A is 0.3. So that means 0.3 minus 0.25 is 0.05, and that's just A without the overlap. I also, before I find out this part, I need to find the overlap between B and C. So the probability of B is 0.4, and the probability of C is 0.2. When I multiply them, I get 0.08, so that is the overlap. To find B, I know that B is 0.4, and it's going to be 0.4 minus 0.25 plus 0.08. So just B is 0.07. And then C, I was told, was 0.2. So just section C, 0.2 minus 0.08 is going to be 0.12. And then I need to work out the outside. So to work out the outside, 1 minus, and then all of these probabilities, 0.05 plus 0.25 plus 0.07 plus 0.08 plus 0.12, and that gives me 0.43. So I've completed the Venn diagram, and I have looked at all the probabilities, and I can probably add my universal set as well outside. And part C says, find the probability of the intersection, well, it's the union, first, it's the union between C and the intersection between A and the complement of B. So we do have a number in every part of the Venn diagram, so that's going to make it a bit easier. I'm going to write the question here. Okay, so it's the probability. Put a big bracket. The intersection of A and the complement of B. Okay, so I'm going to take the bracket first. A is 0.05 and 0.25. Not B. Well, not B is 0.05, 0.12, 0.43. But I want the intersection between those two, which is clearly just that. So from here, what I want is only 0.05. And then I also want C, and C is 0.08 and 0.12. And I want the union between these, which is all of these added together. So the probability that I want is 0.05 plus 0.08 plus 0.12. So that is going to be, get my calculator, what have we got? 0.05 plus 0.08 plus 0.12, and that is 0.25. That's what I want. And that is the end of this section 4.4.